Welcome everyone to our first of 5 cold climate webinar series. We're happy that you joined us today. My name is Stephanie Phillips. I'm the communications manager at Passivhaus Canada. This event is being held by Passivhaus Canada in collaborations with Parks Canada. The purpose of this webinar series is to help inform you on how to meet design and building standards for new builds seeking to achieve Passivhaus certification. Each of these webinars will feature a different guest from across Canada who will discuss his or her experience and involvement in the construction of a Passivhaus certified building. Please join me this morning in welcoming Garth Grunerud. He's the asset manager for the Northern Ontario Field Unit at Parks Canada, Chris Ballard, our CEO at Passivhaus Canada, and Marcel Studer, a certified Passivhaus designer, certified Passivhaus tradesperson. He's a board member with Passivhaus and an instructor with us, each of whom will be doing a short presentation followed by a discussion and some Q&A. If you'd like to ask a question, please either put the question in chat, highlighting, starting with a Q so that we know it's a question, or during the discussion period, please raise your hand and we'll take the questions in the order they're submitted. So thanks everyone for participating. And now I'll hand you over to Garth, who will start the webinar. Enjoy and thanks again.
Yes, thank you, Stephanie, and thank you to Passivhaus Canada for allowing me the opportunity to speak about an upcoming project at Canada's Lake Superior National Marine Conservation Area. The Lake Superior NMCA encompasses a portion of the largest freshwater lake in the world, and by land goes from the tip of Sleeping Giant Provincial Park to just east of Terrace Bay, Ontario. As part of the establishment for the Lake Superior NMCA, a new operations building and public learning center is required. The needs assessment and the building planning started several years ago, and from the start, it was imperative that a few sustainable issues, operations, and a wood-first approach was required. The objective is to have a building that the public and employees are proud of from day one on to the 25th anniversary, and really for the life of the building. In scoping the building project, the NMCA realized the need to reduce long-term operating costs. And we had a look at other high-performance building standards and finally settled on the Passivhaus standard. Passivhaus standard has allowed Parks and the design consultant to work with a set number for the annual energy usage and to discuss operating energy usage throughout the process. The Lake Superior Discovery Center is planned for Nipigon, Ontario, and will serve as the main administration building and visitor interpretation center for the NMCA. The Discovery Center will be approximately 200 square meters, representing approximately a quarter to a fifth of the building. Significant discussion has gone on to this space as energy usage for lighting, display, and projections will be required. The space is being designed for approximately 30 people to enjoy the center and to have a capacity of up to 30 people waiting in the lobby area. The administration portion of the building will serve approximately 35 employees, and the building is expected to operate 7 days a week and be an example of how greening our operations can be achieved. The project is currently in the design development stage and is expected to soon move past to detailed design. The project is anticipated to be tendered at the end of this calendar year. So there's the same photo on this slide, and that is the front face right now for the architectural rendering of the building. Our plan is to have a wood-first approach that allows for this building to be very sustainable, use Northern Ontarian materials where possible, and to service various interpretive actions for both visitor experience, for ResCon, and for using the building for community engagement. So that's the end of the short introduction to this building, and I encourage you to ask questions later on it and to show up to next month's session for more information on this building. Off to Chris, thank you.
Chris Ballard here, CEO of Passivhaus Canada. Thank you very much, everyone, for joining us today. And thank you to Garth and Parks Canada for partnering us on these series of webinars. This project really allows us to introduce what is, and I'll talk a little bit more about it, really what is a Canadian standard, or a standard that has its roots in Canada. And to bring it back to Canada and to allow us all to learn much more. So a little bit about Passivhaus Canada. Let's go on to the next slide, Paula, if you will. The mission of Passivhaus Canada is to make zero emission buildings, and that's operational emissions we're talking about, known and adopted by government, industry, and public. Second, to support government and industry in the transition to these high performance buildings through education, certification, and policy development, and to promote the Passivhaus Institute building standard, which is now globally recognized as the highest level building standard for net zero buildings. So that's our mission, and happy to be again partnering with Parks Canada to bring you a series of webinars to introduce Passivhaus and to introduce and talk about some of the more technical aspects of Passivhaus, and to really put you at ease that this is a building standard, a concept that is easier to understand and to deal with than you might think. Next slide. So Passivhaus Canada, we are a membership-based social enterprise. We do a lot of advocacy. We do an awful lot of education and professional development. We've got a wide range of courses and seminars that you might want to be interested or take. We provide technical services to the industry, and we have members and staff located all across Canada. So we are growing as the zero performance or high performance zero carbon buildings grow across this country. Next slide. I said earlier that the foundation for Passivhaus is Canadian, and it really is. The picture we have here is from 1977. This is the Saskatchewan Conservation House. The principles of Passivhaus were demonstrated here and developed here. In part, built in 1977 by the government of Saskatchewan with funding from the federal government. The question was, could we make a house that could exist in very cold weather that used practically no energy whatsoever to run it? This house is still lived in today, still performing the way that designers and engineers and the tradespeople built it to back in 1977. And it became one of the foundations for the modern Passivhaus building standard. So we've got roots here in Canada. We're very proud to tell Canadian audiences all about our Canadian roots and demonstrate that this is something that none of us should be worried about. So next slide. So why build to the Passivhaus Institute standard? Well, it's about growing for a greener tomorrow, low operational carbon, more and more lower embodied carbon. We know that around the world, governments and industry are moving to reduce their carbon emissions, and buildings are one big way that we can all do that. And that has, of course, the effect on climate change. We know that governments at all levels have set climate emission reduction targets, and they're targeting the buildings that we live, work, and play in as one way to reduce those carbon emissions. So we know that it's important for the industry to be ahead of the curve, to be up to speed with some of the ways that they might do that, because this is here, this is happening. Next slide. I won't go through all the bullet points here. So what's so special about a Passivhaus building? Well, they're affordable. They provide, the original Passivhaus concept was around comfort, health, affordability, low maintenance because of fewer mechanical systems, and overall, actually, when you incorporate and look at operating costs, much cheaper, much more affordable. So there's a whole bunch of reasons why the Passivhaus standard makes sense to builders, architects, governments across Canada. Here are a few of them. Next slide. We like to say there are a number of principles around Passivhaus but what I'm going to do is instead of me going through them, I'm going to introduce you to one of our many experts, Marcel Studer, who is on the conference with us. Marcel has the real hands-on experience and I think can answer a lot of the questions that you might have. And I'll emphasize that in following webinars, we will have other experts. You know, we look to have architects, engineers, whatever you need, whoever you need, the type of expertise you need so that we can reduce anxieties, inform people, and really make this as simple as possible. So I will say thank you for everyone for being here, and I'm going to pass the microphone to Marcel.
Thank you, Chris, and welcome everyone. My name is Marcel Studer. I've been working with the Passivhaus standard in British Columbia for the last 12 years, designing and building to it. So I've got a bit of experience with it. And the last 5 years, I've been teaching for Passivhaus Canada and for a local trades college as well, training Canadians across the board in the design and the construction of the standard. So today is going to be quite high level, just a few high level points for you to get kind of the overall understanding. The typical Passivhaus course when we train designers, consultants, used to take over a week in person, and now we spread it out over 3 weeks in the online format. So it is quite involved. It's definitely based mostly on sound building science. Doesn't mean that it's very complex, and this slide is a perfect example how simple the standard actually is. So under the headline Build Better, we got 5 icons here. We got 5 kind of principles to the standard, and that's really the main focus of the standard. The really most important thing to realize is that the standard is non-prescriptive, so it's a performance-based standard. So it doesn't tell you how you got to build these Passivhaus buildings. It just tells you to what performance you got to design them. So going through quickly through those 5 principles. The first one is really adding more insulation to our building. So super insulating the building envelope. We have to do that in the walls, on the roof, under the foundation as well. So we have to have a continuous layer of insulation. The second one is really boosting the quality of the windows. The windows are the weakest spot in our envelope. That's where we lose the most heat in the winter season. So it is critical that we use high quality windows, high quality window frames, and glazing, triple glazed even in the warmer areas like southern BC. And if you get to the north, we might have to look at, you know, vacuum glazing or quadruple glazed windows as well. The windows also, if they're orientated properly to south on our northern hemisphere, they allow free solar gains in the wintertime. And if you think back, you know, that Saskatchewan house, that's something that was a little bit missing at that original Passivhaus, and that's what has changed in the development of the standard. Really is to open up, you know, more glazing towards the south facade, because we could get access to that low winter sun that nicely comes into the building and then gives us that free sun energy to help reduce the overall heating energy that we need to keep the building comfortable. The third principle is really, and maybe we should do air tightness first, because that has something to do with why we ventilate. So let's do air tightness because it's part of the envelope. So we super seal our buildings, so we're not losing any conditioned air through that envelope. Also with air tightness, we're really preventing moisture to get into our assemblies and condensating within the assembly and, you know, rotting out our structure, etc. There's a whole bunch of other benefits with air tightness. But mainly it's there to add resilience to the building and ensure comfort. The ventilation system we need, obviously, because we're building very airtight, we need a controlled way to bring fresh air into the building. In the wintertime, we don't want to do this just by bringing in unconditioned, really cold air into a building, because that would cool down the building. So we want to ventilate with what's called a heat recovery ventilator, and that's a fairly simple in terms of technology device. It really just works with the surface area of an exchange core. So there is the warm exhausting air that we pull out of our bathrooms, out of our kitchens, our storage areas, is transferring the heat to that cold incoming air. And the technology so far these days that we have an efficiency of over 90% on some of these units. So that's quite revolutionary in a way that we, without any heat pump technology, anything like that, we can just transfer that heat up to 90% to the colder incoming air. The last one is talking about thermal bridge free design, and it's really about paying good attention to the details in terms of having that insulation continuous. So if we have something that breaks that insulation layer, so we have a concrete cantilevered balcony, for example, a steel beam, anything that goes through that insulation layer, that bridges that insulation layer with a material that's highly conductive, then we have disproportional heat flow through that area. So it's actually something that we have to model. It's just not a linear equation. It affects the heat flow disproportionately, and it can lead, if you have a lot of these thermal bridges, it can lead to a lot of heat loss. It can also lead to reduced inside temperatures, which again can compromise the comfort. So that's it in a nutshell, really, and I think that's about as much as I get into building science and technology. The rest are on a bit more high-level things, and we really, under the feel better section here, we really emphasizing the benefits that, and Chris has mentioned most of them already on the previous slide. So we do have, year-round stable indoor air quality and temperature. It's very quiet and comfortable through the seasons. We have a substantial reduction in energy use, and that's probably around 90% in the heating energy if compared to a conventional Canadian building. It is an envelope first approach, so we're not really emphasizing a lot on mechanical systems and technology. It is really doing a good job with your envelope, where your dollar goes further, and it also creates a much simpler to use building that doesn't have overcomplicated mechanical controls. And with all of that, really, we get a resilience, and especially in this time and day, that gives us a really peace of mind that's priceless. So resilience to events like forest fires, like the pandemic we're in, right? So we're more comfortable being in our interior spaces. And really, in the end, a passive house is just a building that's built better, right? And it's not like we're changing to the building industry completely. We're just building buildings better, and we're adding more insulation, we're using better products, and we're doing a better job of air tightness. Okay, next slide, please, Paula. And it's already happening. So, and the Saskatchewan Conservation House behind me was, a long time ago, was the kind of the prototype of a passive house in a cold climate. So that's somewhere in in the middle of Saskatchewan there, in Regina. In the meantime, we have some northern passive house projects that have been certified to the standard. Anything from a multi-unit residential in Smithers, also one in Fort St. John, and even a city town hall in Alberta in the township of Valley View. So these are real life examples. They're all have been finished. They're all occupied. There is data from these projects. There is obviously, plans, details, how the assemblies have been put together, what type of windows did they use, what type of ventilation system. So it's in the passive house world, we always learn a lot from case samples. So this is something definitely that is worth looking into if you're interested in the passive house standard. And I'm not sure what the rest of the program is for these webinars, but we'll probably have one of these people that are involved in one of these projects being part of it at some point. And of course, there's lots of other buildings somewhere else in Canada as well. Again, it is not rocket science. It's based on sound building science, really kind of, high school physics pretty much. So nothing too complicated, really around heat flow, how heat gets transported. And then it's not different from the way we have been building. This cutaway on the right really shows that, we have just more insulation. In this case, we're adding a whole bunch of exterior insulation to our typical platform wood frame. And we spend a lot of attention to the detailing around the air tightness, and still obviously water as well, how we keep water away from our buildings. So that stays all the same. So it's not really anything changes. We're just being a bit more diligent in the planning and a bit more stringent in the execution of our buildings. I can't emphasize enough that it's really a team effort, and something that's happening, and not just with Passivhaus buildings. It's as soon as you want to have a quality project and a high performance project, it's key to spend more time in the planning and model the building in an energy model, get all the specifications nailed down, get before you start breaking ground, you want to have a really good sense of what you're doing. And that's a real collaborative approach. So it's not just an architect dreaming this up in his office. There's all these consultants that will work together, and not just the consultants, also the construction team will be involved in the pre-construction design stage to consult on details that are possible to build, that they have experience, and also obviously in the costing at an early stage. So really, the team effort, we're all in this together. We all can help make our buildings better. And it does make sense. I really love this story. And this is a Passivhaus project in the First Nations around Hope in BC, so the Yale First Nations. And they had a bunch of old single family buildings on their territory, and they were just needing replacing. And the council or the chief really decided to push the envelope a bit and go with a Passivhaus building. And they figured they couldn't afford to replace them with single family Passivhaus buildings, but they could build these fourplexes because they're more compact, and they will provide the same amount of space for their people, and they will be more economic to build. In the end, they were built in a modular prefab fashion in a local company that was close by in Agassiz, and they're built to the Passivhaus standard. So in the end, this family here, they were living before in one of those older buildings. They paid over $200 a month in heat. Now in the new Passivhaus building, they're paying less than $20. It's a huge difference of what they have to pay every month. And obviously, that's just the money and the comfort and everything else that comes with it. How are you going to put a dollar value on that? So we have to start thinking, if you're looking at the financial thing of the financial aspects of Passivhaus and high performance building, we have to look more long term, right? It doesn't have necessarily a quick payoff in a couple of years, but why should it have a quick payoff if we're putting insulation in buildings that's going to last 50 years or longer? So really, we got to look at the life cycle of the building and give that a financial formula value to look at that. So more a long-term thinking, investing into the envelope that's not easily changed after, that's going to last a long time. And Saskatchewan Conservation House is a perfect example, right? It's still standing, people are still living in it. The only thing that might have changed is, they might have put in a newer HRV. Maybe they have updated some of the finishes inside, but the shell, the envelope still stands to this day, and that's 30 years later, right? So that just proves you that this is the right way to move ahead. Okay, I think that's it. Well, we got some more. I don't know if I give it back to you, Chris, for this one, or should I keep going? I can easily speak to it, but it might be something that's more on your end.
Well, you do a lot of the training for us, Marcel, involved in a wide variety of areas. So, I'll simply say that one of our missions is to close the skill gap through training and education, and to work with municipalities, social housing providers, looking to build to these more ambitious targets. And we'll continue on with our advocacy and our education and our engagement with all levels of government. And, I would invite anyone who's on the call today who wants to learn more about Passivhaus, who maybe has a question for us. We'll answer those we can on today's webinar, and those we can't, we'll get our engineers and architects involved. Thanks, Marcel, for a good overview.
Thanks, Chris. Yeah, and I kind of emphasize enough again that there is a lot of offerings that we provide for education, anything from webinars like this to full-fledged courses, and it's definitely the right way to start and to get yourself educated on it. And not just if you're a builder or a designer, it's very important that the clients understand as well what the standard involves. People who own the buildings and run the buildings as well. So we have quite a diverse offering of different courses.
There are a couple of questions at least in the chat box. Now, Marcel, Frank Crawford asks, Frank asks a very detailed question. I'm not sure if that's something we can answer. If I certainly can't answer it. You might be able to answer it, or we may be able to take this offline and get back to Frank directly.
Yeah, I think we have to talk to a mechanical engineer, like one of our instructors, like Michael Nemes, might be perfectly. It's about the COP, the coefficient of performance of a heat pump, and how exactly it gets modeled in the Passivhaus software. I know kind of the top level about it. I know that there is a different temperature models that are in there. It's not just at its best performance that it gets modeled. But I don't know the exact details of what the temperatures are and what the numbers are there. So I think we have to take that offline. But the next one, he has the question about why not to expand the focus to include embodied carbon and pre-occupancy carbon. It's a very good question. And actually, that is happening. PHI, that's the Passivhaus Institute in Europe, was kind of the mothership of the standard, announced last year that this is something they're working on. So maybe for those of you who are not familiar what embodied carbon is, right? So it's all the materials that get put into a building. They have a certain amount of energy getting used to make them. So not just to make them, also to source them. So if it's something that has to be dug out of the ground or cut down, that's all included in that calculation. And then they figure out how much CO2 gets emitted through that process of making that material, and then it obviously gets locked into the building. So the Passivhaus standard is really good at reducing the operative carbon. So by running that building, you're using less energy and you're reducing the carbon. It doesn't yet have any standard around embodied carbon, but that's gonna happen fairly soon, as they're working on it this year, and we'll see something out of it.
And in the meantime, if I can jump in, Marcel, in the meantime, Passivhaus Canada, it's one of the hot topics, we'll say, from our members. We have an introduction to that, some tie-ins with the PHPP software, and certainly a lot of discussion going on behind the scenes about embodied carbon, a lot of information sharing, and partnering with people like the Canadian Wood Council, talking about and looking at mass timber, those kinds of things that help with the embodied carbon.
Great. So I encourage everyone to ask any questions here. There's no stupid questions. I always say that to students. I don't have really a sense of how much you know about Passivhaus or how little. So any question as well. We have some time now. We have almost half an hour to go over some questions you may have. And you can unmute as well and just ask them. You don't have to type.
Yeah, pop your hand up and we'll get you into the conversation. Because I know Marcel does a really good presentation, but I don't think we've answered all the questions around Passivhaus and what Parks Canada is doing. But we'll unveil more in the coming webinars. So happy to take any questions now, or happy to take, if you want to contact us on our website, passivhauscanada.com. Happy to take any questions you may want to throw at us that way. So. There's an interesting. Why don't you take that, Marcel?
Okay, a question from Jesse. How do you deal with conventional dryers and fireplaces in Passivhaus? Very good question. Maybe I'll start with the fireplaces. First of all, having a fireplace in the Passivhaus would actually overheat the Passivhaus. The output of a conventional fireplace is way too high. It gives us too much heat. And it can't be, modulated fine enough to provide that little heat that we still need in the Passivhaus. So it doesn't make sense from a heating perspective to put a fireplace in a Passivhaus building. But you might want it for more romantic reasons, right? That's quite common. But the other thing is, it's a big gaping hole you have through your envelope, right? You have a chimney that either goes out the wall or through the roof, etc. And that's a big hole if you're not sealing it off. So it is possible to have a fireplace if you really want to in a Passivhaus, but you got to have dampers, you got to have makeup air. You don't want to upset that balance of, the HRV, fresh air coming in by using that for combustion in a fireplace. So it is possible. It's not done a lot because of those reasons. To the dryers, conventional dryers, we're all used to, with the blasting hot air at our clothes and then exhausting it to the outside. Again, you got a hole in your envelope, thermal bridge, a hole in your airtight layer. So we not encouraged to do that. It is possible, again, if you want to, with using some dampers that are controlled by the dryer, that you open up the damper and then the dryer comes on. But what we recommend mostly is using a condensating dryer, so a ventless dryer. First of all, they use less energy. They actually run on 110 instead of 220. It takes a bit longer, that's a drawback, but it works like a dehumidifier. It just takes the humidity out of the clothes and then sends it to condensate down the drain. So that way we don't need to have that hole through the envelope and we're not compromising our envelope.
And I will say, Marcel, if I can jump in there, because I don't live in a Passivhaus. It is a dream one day to do that. But my dryer has broken. And when I went looking for condensing dryers, the next generation, the heat pump dryer, now being sold in big box stores. So that European style is now here, readily available. Well, as readily available as any appliance in today's marketplace, but they're here. They're not that much more money, and I am told the one that I've ended up buying is about 40 to 60% less energy usage. That, and it's not. I don't have that 4-inch hole blowing conditioned air to the out of doors. So this is not future technology. It's been used for years in Europe. It's now readily available here in Canada.
Yeah, there's another way to forego this problem is you can put your dryer outside your thermal envelope. So you can put it in a semi-conditioned space that you might have, like a mudroom or part of a garage or something like that. Then obviously you don't need to worry about because it's outside your Passivhaus envelope.
Yeah. So Kim asks us, Marcel, the hardest part, what's the hardest part of Passivhaus construction? And Kim is saying that tight envelopes seem very labor intensive. What's your experience?
Actually, the air tightness is not necessarily the most labor intensive. I think it's a combination. I think obviously it depends how you're building your assemblies. So it really depends on the type of wall you do. So it can be also prefabricated. So you can save a lot by taking advantage of prefabrication like flat pack or modular. I think it shouldn't take necessarily longer than a conventional building. In my experience, it's been very similar. It really depends. You have to get some systems going within your practice that you're getting used to and learning. So there's obviously a learning curve, but once say you're on your second, on your third project, you're repeating the details that work for you, it's not going to take longer overall. And just talking maybe about air tightness, what's very common these days is getting air tightness with your sheeting membrane, with your WRB, so your water, like your building paper, your like Tyvek, Typar. So you get your air tightness on the exterior of your framing rather than to chase it on the inside between the floors and around all the interior walls, etc. So that's just one example of maybe looking at a different way of doing things, and I could simplify it and also make it more economical.
So next question is, how do you deal, I think this is the next question, how do you tie in decks to a passive house? It's
very good question, and that really talks about thermal bridge-free design, right?
Yeah.
So with wood, we're a little bit more, it's a bit easier, it's a little bit more forgiving, right? Wood is actually a really good structural product that's not super highly conductive if you compare it to steel and concrete. So we could have, a few beam penetrations of wood going to the exterior and then somehow a cantilever support it. If you want to completely avoid that, you would almost build like a self-supported deck structure that's just snug up to the building rather than having it hanging off or being supported by the building. So that would eliminate thermal bridging even more. And then if we're talking about concrete and steel, again, it becomes more important to deal with that bridging element. And there is some products for concrete. There's a structural insert you put in to create a cantilevered concrete balcony, and the insert breaks the conduction there right in line with your windows or your envelope, and it will work for a passive house.
Yeah, good. Couple of questions that I think we actually can tie together. How do you deal with kitchen top air extraction, and why do we not recommend gas stoves? I think those two tie in together.
Yeah, good one. Yeah. It has to do with the ventilation of the kitchen. So what we're trying to do in Passive House is actually using the HRV to take that stale air out of the kitchen area. We're not hooking it directly up above the stove. We're actually, it's a bit further away. What we recommend really is having a hood fan that has a carbon filter in it, takes the grease out and the smell. And then basically just leaving the air within the kitchen. So it just spits it out again above the hood fan. And then maybe like 6 feet away, there's an extract port from the HRV that is continuously drawing air away from the kitchen. And when we cook, we actually have, and also in the bathrooms when we have showers, it's the same thing. We don't use bathroom fans, we use the HRV. There is a boost mode in the HRV, which can be activated by a remote control or by a wired switch, which will ramp up the fan speed of the HRV to a higher level to really take away that, polluted air or high humidity air for a short period of time. So that's typically the way it's done. And if we're using gas, we're by code not allowed to do that. So if you have a gas stove, then you have to direct vent it, which again is possible, but then you need to look at dampers and makeup air and all sorts of bit of more of an engineering feat to do that.
Right. I know, Marcel, when I toured one of my first passive houses, the lady of the house was quite, I said it sounded like a very complex mechanical system. And she delightfully told me, no, there were two buttons on her particular setup, and she called one button normal and the other one was party mode. So when people were coming over, the house was going to overheat or there was going to be extra moisture from cooking, etc., she pushed the what she called party mode, and it dealt with excess heat, excess humidity. I like that name for that button, actually. I might use that myself one day. So we have another question and Frank, I hear you about drying your clothes naturally. Exactly. Everyone, if possible, put a line up or get a wooden horse to hang your clothes on. Then you don't have to run a dryer or use the dryer as much as you might. We have a question about solar gain and energy efficiency. How do we make that balance? How do we deal with that in a passive house? We talk about solar gain, but even in a northern climate, we can have too much solar gain, perhaps especially in the summertime.
Yeah, that's a very key question, and it actually has happened with some of the early projects in Canada and in other places in the world, that because we're building this really tight envelope and we're kind of designing with solar gains in mind, it can actually lead to overheating in the summer months. So we got to deal very carefully. Well, this all happens in planning, obviously. So in the model, in the Passivhaus planning package, in the model we use, the energy model, we simulate shading. So shading, that's maybe some trees that are surrounding you, buildings that are surrounding you, mountain ranges. So that's kind of further away. But we also try to control the direct amount of sunlight onto the glazing in the summertime with exterior shading devices on our building. So on the south side, it's quite easy to do that with a little, overhang, like an eyebrow or like a brise soleil, we call that in architectural language, because the sun angle changes so much right from the winter to the summer. So in the summer, the sun is much steeper in the sky. And if you have something directly above the window that's shading it, you can completely keep that sun energy away. The critical sites are the west, especially, and then the east a little bit as well, because even in the summertime, the sun is shallow. So the only way to really shade those windows is using an exterior full shade that goes, covers the windows. So a Venetian style, kind of, European style shading device, or something that moves across a slider, or anything that can shade the glass. And yeah, that's something I have to maybe rethink a little bit in our culture of designing buildings. For people, if you have been in the Mediterranean climate in Europe, it has been done there forever, right? So you go to the piazza in Italy in the middle of the summer, in the middle of the day, you see all the shutters are closed. Like, it's not everyone left for vacation. No, they're keeping that building cool by closing those shutters and minimizing the heat gain coming in through the windows. So very good question. Maybe that's a very important point that we teach. You have to be very careful with the way you model a building and you shade in the summertime.
Yeah, lots of questions coming in. There are a few, Garth, maybe are more specifically directed to you folks, talking about PHI standard. Is this project targeting PHI or the more relaxed American standard? I don't know if you want to comment on that right now. Passivhaus Canada, just for the record, is the affiliate with the Passivhaus Institute, which is the globally recognized standard for the highest standard for high performance buildings. So we are definitely working with Parks Canada and others to hit that PHI target, not a more relaxed one. A comment, and I don't know, Garth, raise your hand at any time or jump in if you want to correct me. But I know, Paul has a question about hiring consultants, the architects, the engineers who know how to design to Passivhaus is challenging in Canada. Do we have a solution? I think our big solution, Marcel, is that, last year we taught over 2,000 people on our designer consultant course. That's 3 courses, and we are probably the world's leader right now in those number of people taking the Passivhaus Institute exam to be a designer consultant. That's really a program for architects and engineers. But in our mind, the biggest way to gain acceptance is just to educate people. Not everyone has to take that very intensive course. Contractors, we would recommend take our 120A, our introduction course, so that they're better able to work with engineers and architects and really understand the principles. So we're doing it, frankly, we're trying to address that by educating. And we've had good success at doing that. And as I said, well over 2,000 people last year alone took our courses. real growth here in Ontario, quite frankly. We were founded in British Columbia, where they have adopted the green building strategy. In Ontario, the growth in Ontario over the past year has been absolutely spectacular. So this is one more example of that. So Paul, I don't know if that answers your question, other than we've got to get out and educate as many people as we can. We find that after about an hour into one of our classes, people become advocates for Passivhaus. When the penny drops and they understand what it is really all about, then they become, it's not some bizarre, foreign, difficult concept. It's really quite simple. The concept and principles are quite simple. And as we like to say, it's not rocket science, but it is building science. So let's look for another question. I hope that answers, Paul.
There was one by Gerardo about standard construction materials.
Right.
Good one. I can speak to that. Yes, you can build your wall in any way that you have been used to. You just need to make sure that overall you got enough insulation that it works for the Passivhaus standard. So again, that's the beauty of the performance-based standard. There's no prescriptive path to this. And then there was one by Celia, was a bit more specific again that I can answer. She's looking at a retrofit. So first of all, there is a retrofit portion to the Passivhaus standard, which is slightly slacker than the new build one, because they're realizing that it's harder to retrofit the building. And her question is about, I guess she's in a duplex or a townhouse kind of scenario where she has a party wall between her unit and the neighbor, and what she should do to insulate that wall. First of all, it's not that super critical that that wall is insulated, right? You got a conditioned space on the other side. It's not like you have an exterior wall that you're in the winter. I think, Celia, you're in Edmonton, if I remember right. Quite cold up there. So obviously, if you can put some insulation in there on your side, typically if it's a wood stud frame, that would have 2 layers, 2 2x4 walls. So you can maybe take the drywall off on your end, insulate that 2x4 wall, and that would definitely help already. So a little bit more into detail here, but I hope that gives you a little bit of an idea of what's possible.
Yeah. Oh, we have a hand up. Philip has his hand up. Paula, can you unmute Philip for us?
Great.
Go.
Yeah, we're opening up a quartzite stone quarry here, which is one of the cleanest rocks you can find around the world. It's probably going to be up and running this summer sometime, but we'll be getting a hold of you to contact you about getting some of the rock there for your building.
Okay.
I guess that's for
Thank you, Philip.
Yeah.
Are you referring to the Parks Canada building, Philip?
Yeah. The kind of rock
Perfect.
we use, there's no contamination involved.
Good.
We look forward to any local building materials as a possibility.
Yeah. And Philip, drop us a line too, Philip, because I'd be quite interested to hear about your quarrying process, and you know, because people are always asking us about suppliers.
Okay, thank you.
Good. Thanks, Philip.
Okay,
Marcel,
I can come back to Christopher's comment. He had one on how is the Nipigon project making out with hitting the Passivhaus numbers. So throughout the process, we've been going for about a year now. And throughout the whole design process leading up to design development now, we've been passing. Our consultant's been very good about working with our Passivhaus certifier, who's actually in Germany, and making sure that we're hitting positive numbers before they submit. So their iterations and analytical analysis are making sure that we're hitting, as we've written that as a design requirement and as a requirement to the consultant, that they can't provide us any deliverables unless it's meeting the target. So we've been meeting that so far in the project. We hope to continue to meet that. And we are using the Passivhaus Institute standard. We're not using a more lax version of Passivhaus, such as the US. We are sticking with the Passivhaus Institute, and it's been very productive so far. And I can speak roughly to Paul's comment as well. The hope with our Parks Canada Lake Superior Discovery Center is that the more projects we have, the more consultants and professionals we will have that have experience on these projects. And hopefully this one leads legacy projects or contractors' legacy skills that they can use on other projects. And maybe we don't have more passive house projects, but maybe we have higher efficiency than the minimum standard currently being used in Ontario and throughout Canada.
Yeah, good point.
Yeah, Sonia was asking why passive house for you, Garth. I guess you kind of mentioned about the quality control aspect. Any other reason why particularly you picked that standard?
The quality control aspect is very significant to make sure that whatever's being put on the drawings is what will be constructed. But why we picked passive house was basically for climate resilience, comfort, low maintenance is very key, and durability. Where Nipigon is so the closest major town is Thunder Bay, Ontario, where I'm located, which is about 130,000 people. Nipigon's an hour and 15-minute drive down the highway. And with the limited maintenance and other services that are located in a smaller town, we looked at passive house as providing a very durable, low maintenance. So rather than having a boiler system or gas service where we need inspections regularly, we're going to have an electrical-based heating plant that will not require much in the way of maintenance. So where I see a lot of our historical buildings in my business unit for Northern Ontario, we're spending quite a bit of money on utilities. And with this building, we're hoping for it to be net zero or net positive. So this site will be able to spend more on our obligations for research and providing services than it will on maintenance and infrastructure.
Great. I think there's one for Chris here, something about, just trying to find here, from Ilan, how to engage social housing in non-extreme weather areas, for example, the GTA, to use passive house while they are more economically focused.
Yeah.
Social housing in GTA, you have some experience.
Yeah, right across Canada, we've been closely engaged with as many social housing / affordable housing organizations as possible to introduce them to the Passive House Institute standard and to introduce them to the refurbishment, the retrofit standard, which is known as EnerFit. We have major projects going on right now with Toronto Community Housing Corporation to assist them with renovation, the EnerFitting of a number of their towers. But there are some other great examples in the GTHA. Hamilton has been doing some really exciting things. I think the largest EnerFit of a residential building is the Ken Sobel Tower in Hamilton. You may be aware of that. We've got for a small organization, we've got our fingers in a whole bunch of pies. But for the reasons that Garth talked about, the operational costs are lower, the maintenance costs are lower, the quality assurance is much higher. We're finding that when we talk to social housing organizations, they really need that and buy into that. If you have any contacts, anyone has any contacts, we'd love to talk more.
Great. There was one question by Florent. Is it possible to adjust the passive house criteria, reducing the expectations, I guess the metrics, for projects located in the Canadian Arctic area? And maybe I can answer this. It's very hard to build to the passive house down in the Arctic areas, and especially with the materials that are available at currently of building materials. Like we will need some better windows. We might need to look at vacuum insulation to make it even feasible. There is no provision at the moment to make it easier for the Arctic climate, and no FIUS has climate-dependent different grades of their standard. PHI doesn't have that. And the reason for it is really it's laid out around the comfort, around having no condensation on interior surfaces. And if we start diluting those criteria, that will disappear, and it will make it a not so comfortable building anymore. And the other thing is also it's laid out that it can operate with a minimal mechanical system. Actually, the classic way to heat a passive house is using a fan coil, electric or hydronic, within the supply air of your ventilation of your HRV. So you'll lose those advantages as soon as you start moving away from the standard. And there was a good comment by Frank. There is a low energy building standard also by PHI that you can use to certify buildings. So that might be a way to go if it's not possible to go full passive house.
Yeah. And I know, Marcel, that it may offend the purists in the audience, but you know what we tell people is you aim for Passive House Institute standards, and even if you miss, you've still got a far better building than you would have had beforehand. So you know, shoot for the stars. It may be far more difficult in Arctic regions. We get that, but you shoot for the stars, and even if you miss, you're going to have a better building than you would have if you built the code. That's for sure. Other questions?
Yeah, there's one by. It's something about a proprietary passive house fireplace system by Foti. I haven't seen that particular one, but I'll look into it. Thanks for the heads up.
Yeah.
Typically, you see little European style fireplaces, which is like the wood pellets one, you know, that automatically feeds that little combustion. And that's possible to heat a passive house like that. And there is examples from Europe where they actually use a wood source to heat their passive house, but it's not putting, you know, big logs in and having your conventional fireplace. So it's a very small combustion chamber with an auto feed for little pellets that, you know, put the exact amount of heat out that you need for a passive house.
You may have to, if you're going to build. So what I'm hearing from you, Marcel, is you know, my house has always had a high efficiency wood fireplace in it, very romantic, very practical, and a drafty old home that I'm in now. But in my dream house of the future, I'm going to have to, if I want a wood fire, I'm going to have to put a pit outside or something like that to enjoy a log burning. Exactly. If we're going to do that.
Yeah. There's a few more questions. I know we're at 10 now, so if you're happy to hang around, I'm happy to answer those quickly. So one by Martin about a foundation that is on piles, which can be quite common in certain areas, I guess. If that's possible. Yeah, that is possible. It really comes down to what you do at the supporting part where the building sits on the pile. So you need to have some kind of a detail there that eliminates the thermal friction between the pile and the insulated building envelope. So I can't tell you off the hand what the best way is to it, but you know, there's lots of different ways of doing this, but you just have to pay attention to that. And then there's a general question if by Stephen for the future sessions, if we're going to touch on more existing building renovation, rehabilitation. I think we have a whole series planned on retrofits, right, Chris, eventually, maybe later this year?
Yes, later this year we'll have a whole course on retrofits, our InterFit program.
So yeah, look out for that, Stephen. Then there's just thank you from Sonia. Gerardo is asking where he can find ERVs in Canada. It depends what size, right? There is Swigon is like a large one for big buildings. They have a plant in Toronto. Then Stender is a brand that's manufactured half in Europe and half in the US, and that's smaller units. So I'll type it in here because it's a German word.
Yeah. And while you're typing, I'll let people know that a lot of our work that we do at Passivhaus Canada is to work with industry associations and individual manufacturers. So we do a lot of work with fenestration, with HVAC, to not only talk to them about the marketplace transformation that's happening right now as we speak, but to help them get prepared for it, to help if they want to certify their windows or their systems. We try to help to streamline that and to make it as easy as possible. So not only are we trying to provide the marketplace with the trained professionals, the trained builders, we're also looking to do our best to make sure that you've got the systems you need, the windows you need, the mechanical systems you need to actually build those passive house buildings.
Great. I think that's it for questions.
Yes, thank you.
Thanks very much.
So I guess that this concludes our first in this series of webinars about the great work that Parks Canada is doing. And so thank you, Garth and Sonia and everyone who played a hand in getting us to where we are today. This is very exciting. And I echo what Garth said, that we hope through this process and through this Parks Canada build that there is a legacy among contractors and building professionals, tradespeople in the area that they can utilize for future high performance building. Whether it's Passivhaus Institute standard or not, it's really important that we all start building to a higher level of building. Building codes, national, provincial building codes will be demanding it shortly. So it's really important that we help you be prepared for that. And we're really excited to offer these webinars. A lot of good information, lots of good feedback. So thank you, everyone. Have a good rest of the day. Garth, do you have anything you want to say before we wrap it up?
No, just thank you for giving us the opportunity and a platform to work with Passivhaus Canada. And thank you, Marcel, much appreciated. And I think somebody might be able to speak to, we're the first Wednesday of next month for the next session, I believe.
Let me ask Stephanie about that. Stephanie, you know the schedule. And you're muted.
Sorry. So the next one is in April, and we will be chatting with about, sorry, I have to, case studies in cold climate.
Okay. So some practical, real experience about cold climate building. So great. Do we have a date for that, Stephanie? Are we still nailing that down?
It will be the first Wednesday in April.
Okay, excellent. First Wednesday in April. We'll see you all. Hopefully we'll see you all back here. And without further ado, thank you, Garth. Thank you, Parks Canada. Thank you, everybody, for being on today's webinar. Thank you, Marcel, for your expertise. You know, I'll just make a quick comment. One thing I have found about the Passivhaus community is how much it shares with one another. By day, we have fierce competitors competing for business, but in the afternoon and the evening, we have webinars, social events where folks are hosting or hoisting a cup of coffee or perhaps something stronger and working together to solve common issues. So I encourage you to become part of the Passivhaus community. There's lots to learn simply through our social networking events as well. Lots of education that we can help you with. Look forward to meeting you all soon. Take care, everyone. Be safe.
Thank you.
Thank you.
Bye.